Welcome to Brunda Engineering Academy. In this video, we will discuss about the topic fluid mechanics subject, properties of fluids, the properties surface tension, capillarity, and cavitation. Okay, these three are the pending properties. In the previous videos in our channel, we are already discussed about the remaining properties of the fluids. Okay, so this video can be helpful for the both B.Tech and diploma, for both B.Tech and diploma in the gate point of view and ECET point of view also, and the subject point of view also. So now let us go about the surface tension. Surface tension. From the fundamentals I will explain. Please follow the channel. Surface tension means, for example, the surface tension is simply written or symbolic representation is sigma. First of all, that is the basic definition for the surface tension is force per meter length on a liquid. Force per meter length on a liquid, that is surface tension equal to force per unit length. Force per unit length is the surface tension. For example, I am considering a vessel and it is the surface of water. This is the surface of the liquid. The force acting on the top surface per meter length. The force acting on the top surface per meter length is the surface tension. This is the basic definition. Actually, this surface tension is the tensile force. The tensile force acting on the surface of a liquid. It is the surface of the liquid in contact with a gas or liquid. Okay, in contact with a gas or liquid on the surface between two immersible liquids, such that the contact surface behaves like a membrane. Behaves like a membrane under tension is called surface tension. Simply, the thing is the force acting on the surface of the liquid per unit length is the surface tension. Okay, so here it is the force per unit length. Force per unit length. So here that is sigma equal to force by L. Now what are the units? Newton, force is Newton and the length is meter. It is the SI unit for the surface tension is Newton per meter. Or Newton can be written as 1 kg force also. 1 kg force also. So kg force per meter. It is also the unit for the surface tension. Now what are the dimensional formula for the surface tension? What is the unit? Newton per meter. Newton per meter. Newton means kg meter per second square by meter. Then the remaining term is kg per second square. Okay, by the simplification we get kg per second square. Then kg second power minus 2. Now what are the dimensional formula means? MLT. Here M is mass. Mass is kg. So power coefficient is 1 only. Next L. L means length. There is no length here. So L power 0. Next T means time. Time units here second. Second having the power coefficient minus 2. So it is the minus 2. So the dimensional formula is the M L power 0 T power minus 2. The key concept is surface tension is the force per unit length is the surface tension. Units are Newton per meter, kg force per meter. Dimensional formula is M L power 0 T power minus 2. Next, in the problematic in this concept, the problematic is here I am considering three different cases. The first case is the liquid droplet. Liquid droplet. liquid droplet, the example is the rainwater. How it will looks like in this way, liquid droplet. Okay, so for this liquid droplet, what is the surface tension? The bit is asked like this. The concept is the surface tension for liquid droplet. Surface tension for liquid droplet is given by the relation PD by 4. PD by 4. Sigma is surface tension. P is the pressure intensity. That means pressure inside the droplet. Pressure inside the droplet. How much pressure inside the droplet? Inside the droplet. I am writing here inside the droplet. And D is the diameter of droplet. Diameter of droplet. Diameter of droplet. Diameter of the droplet. Now, if you observe, suppose in the gate point of view and ECET also, they give the diameter. The diameter is given. If the diameter is given, this is the diameter. Then you can find out the pressure inside. Pressure. If you have the pressure, if P value is given and D value is given, then you can easily find out the surface tension. Or in some of the cases, they may go directly the surface tension. They may ask about the pressure intensity in the liquid droplet. Okay, so that problems also solved in the next video. You don't worry about that. How in the previous questions they may be asked. Okay, that will be discussed in the next video. Next second case for it is the liquid droplet or rainwater also liquid droplet. Next one is the halo bubble. Halo bubble. Halo bubble or soap bubble, halo bubble or soap bubble. For that halo bubble or soap bubble, we can write sigma. That means the surface tension here. Surface tension of the halo bubble. Sigma is given by PD by 8. PD by 8. For the halo bubble or soap bubble is sigma equal to PD by 8. Okay, using this relation, you can calculate the halo bubble is nothing but in the circular form. Okay, spherical form. Okay, next the third case is the liquid jet. The third case is liquid jet. For the liquid jet, sigma equal to PD by 2. PD by 2. So these three are the very important relations for the liquid droplet or rainwater. Liquid droplet or rainwater. Liquid droplet or rainwater. We will use this relation sigma equal to PD by 4. Whereas for the halo bubble or soap bubble, we use sigma equal to PD by 8. For the liquid jet means suppose a jet of water will be strikes on the blades of the turbine like this. In this way, we can take it as the jet form. You can take it as the jet form. So for that cases, we can find out the surface tension sigma equal to PD by 2. Okay. Next, one important note is this surface tension. This surface tension depends upon the force of attraction between depends upon the forces of molecular attraction. Molecular attraction. Suppose we are having the gases molecules. This surface tension will be depends upon the attraction between the molecules. Attraction between the molecules. Okay, it is a very important noted point. Surface tension depends upon the forces of or force of attraction between the molecules clearly. Next, another case, one definition or one phenomena, cohesion. One phenomena that is cohesion and addition. Cohesion and addition. Cohesion means the force of attraction. The force of attraction between the molecules of the same liquid. Suppose here I am considering a vessel. In this vessel, we are pouring that with water. Here clearly water. Okay, it is only one type of liquid. Okay, now these are the molecules. So the force of attraction between the molecules of the same liquid, the force of attraction between the molecules of the same liquid, that phenomena is called as the cohesion. Cohesion means force of attraction between the molecules of the same liquid, then cohesion. Next, another property is the adhesion. Adhesion means the force of attraction between the molecules of the different liquids. Suppose two liquids in a vessel, suppose water and milk. If you combined with these two components, these two type of liquids, then the molecules also attracted together. Or if you combined oxygen gas and hydrogen gas, okay, then you combine that, for that molecules will be attracted together. That means two different liquids, two different gases. Okay, so that type of property is called as the addition. Force of attraction between the same liquid is the cohesion. Force of attraction between the different liquid is called as the addition. Okay, this surface tension is clearly caused due to the cohesion only. Surface tension is clearly caused due to the cohesion. Okay, now this is about the property of surface tension. Next, coming to the next property, that is capillarity. Capillarity. Okay, coming to the concept, that is capillarity. Capillarity means it is the rise or fall of liquid. The phenomena of rise or fall of liquid. That means suppose it is a vessel, big vessel having major diameter. Now I immersed a small glass tube. I immersed a small glass tube. That means in the reversed position. Then what will happen? The water will be rises. That means this is the rise of liquid. This is the rise of liquid. The rise of liquid or fall of liquid when the glass tube is immersed reversely. So then that is called as the capillarity. Okay, rise of liquid. Rise of liquid is the capillary rise, and fall of liquid. Fall of liquid is called as the capillary depression. Capillary depression. Observe the difference. If the liquid is rises, then that can be called as the capillary rise. If the liquid is falls down, then that is called as the capillary depression. It is the rise or fall, means having the units of, it is the symbolic representation of the capillarity is the H. Okay, rise or fall means it is the distance. The units are the meters of liquid or centimeters of liquid or centimeters of liquid. Okay, so this is about the capillarity, and here the capillarity will be depends upon which parameter. Capillarity will be depends upon the three parameters. One is the specific weight of the liquid. This liquid capillarity depends upon specific weight of the liquid. Next, second is diameter of the tube. This is the diameter. So this is the diameter of the tube. If you observe, if the diameter of the tube is very small, then rise is very high. Okay. So if the diameter is very large, then the rise of liquid is very low. Observe the difference. If the diameter is increases, the rise will be decreases. If the diameter is decreases, that is then the rise will be the very high, and the capillarity is also depends upon the surface tension of the liquid also. So finally here important point is capillarity depends upon the specific weight of the liquid, diameter of the glass tube, and the surface tension of the liquid. Okay, next another point is capillarity is caused due to both cohesion property and addition property. It will be caused due to both cohesion and addition, whereas surface tension is caused due to only cohesion, only cohesion. Observe the difference. Surface tension is caused due to only cohesion, whereas capillarity is caused due to both the cohesion and adhesion. Okay. Next, how can you calculate this capillarity? Suppose the formula is capillary raise H equal to 4 sigma cos theta rho GD. 4 sigma cos theta rho GD. Here sigma is the surface tension of the liquid. Previously we discussed, whereas rho is the density of the liquid. Rho is the density of the liquid. G is always, it is the constant one, 9.81 meter per second square. Next, D is the diameter of the glass tube. Diameter of the glass tube, which we have immersed earlier. Okay. For water, if you calculate that capillarity for water, this theta equal to 0 degrees. Okay. If you calculate that mercury, the theta equal to 128 degrees. That theta is the angle of contact between liquid and glass tube. Angle between contact between liquid and glass tube. In the next video, we will discuss about the problems. How can you solve the problems? For water, theta is 0 degrees. For mercury, theta equal to 128 degrees. These two are the fixed values. And surface tension and density. Density is density of the liquid. Which liquid we will calculate. Okay, that will be decided. Okay, this is about the capillarity. Okay, majorly the remembering points are capillary raise or fall of liquid is called as the capillarity. Capillarity is caused due to both cohesion and adhesion property. Units are meters of liquid, centimeters of liquid. Specific capillarity is depends upon the specific weight of the liquid, diameter of the glass tube, and surface tension of the liquid here. Next, the formula is here H equal to 4 sigma cos theta by rho GD. For water, theta equal to 0 degrees. For mercury, theta equal to 128 degrees. Okay. Next, another property is clear. The last property is cavitation. Cavitation. Here, cavitation. Before explaining about the cavitation, you should know about one parameter, that is vapor pressure. Vapor pressure. Vapor pressure means suppose if you consider the liquid water, if you increase the temperature of the water, the water will be converted into the vapor. Okay, yet which the corresponding pressure is called as the vapor pressure. Okay, if you consider the water and increase the temperature, then the water will be converted into the vaporous form. Yet some temperature, that water will be converts from water to vapor. That temperature, that corresponding pressure is called as the vapor pressure. If for this cavitation means it is the phenomena of formation of bubbles and collapsing of the bubbles. Formation and collapsing of the vapor bubbles when the pressure falls below its vapor pressure. When the pressure falls below its vapor pressure. When the pressure of the liquid is less than the vapor pressure, then some bubbles will be formed and collapsed. That phenomena is called as the cavitation. Generally, this cavitation is occurred in the reaction turbines and centrifugal pumps. Centrifugal pumps. It is at the disadvantage to the any hydraulic machine. It is the disadvantage. That means it is the bad property to the hydraulic machines. So you have to avoid that cavitation problem. Why? Because the formation of the bubbles and collapsing means some forces will be developed there. Due to that forces, some vibration will be occurred in the hydraulic machine. Some vibrations will be occurred in the hydraulic machines, and due to this collapsing of the bubbles, some noise is also developed. Noise is also developed. So we have to avoid these two phenomena. That means vibrations and noises. This is difficult to run the hydraulic machine to smooth manner. So our as an engineer, our target is to avoid the cavitation problem. Okay, so these are the important properties here. In this video, we covered only these three properties, and the remaining properties are explained previously. If you're not observed that, please watch our channel and please see the previous videos also. In the next video, we will discuss about the different previously asked problems and previously asked questions in the gate point of view, assistant engineer APPSC examination cases, and ECET previous questions. These all will be discussed in the next video. Okay, if you like this video, please share to your friends and subscribe our Brunda Engineering Academy channel. It is a platform to the poor and needy people to share the knowledge, engineering knowledge without any fee.